Tebufenpyrad is an insecticide and acaricide widely used in greenhouses. It is a white solid chemical with a slight aromatic smell. It is soluble in water and also in organic solvents. Tebufenpyrad is a strong mitochondrial complex I inhibitor. Like rotenone, it inhibits electron transport chain by inhibiting the complex I enzymes of mitochondria, which ultimately leads to lack of ATP production and finally cell death. Tebufenpyrad is used mainly in greenhouses around the world. It has been registered under various trade names, aromatic, pyranica, in countries like Australia, China, and certain South American countries. It is registered in USA for use on ornamental plants in commercial greenhouses. The data available presented enough evidence to support unconditional registration of Tebufenpyrad for use on ornamental plants in greenhouses. It is mainly used in greenhouses, and the major form of exposure is through occupational exposure, where this chemical is manufactured or used extensively. The possible routes of exposure are through inhalation or dermal exposure. Since it is used in ornamental plants, the exposure through food is limited. The LD50 values for various laboratory animals are as follows. LD50 rat, male, oral 595 mg per kilogram. LD50 rat, female, oral 997 mg per kilogram. LD50 mouse, male, oral 224 mg per kilogram. LD50 mouse, female, oral 210 mg per kilogram. LD50 rat dermal greater than 2000 mg per kilogram. Hydroxylation is the major and primary biotransformation of Tebufenpyrad, reported both in vivo and in vitro. Ethyl and tetrabutyl groups are the targets of hydroxylation. The alcohol groups are oxidized to carboxylic groups, which can then be conjugated with other groups in vivo. In rodent studies, it was shown that 80% of the pesticide was absorbed mainly in the digestive system within 24 hours, the major metabolites being the hydroxylated forms. Most of the compound in its metabolites were excreted through feces and urine. There was no evidence of accumulation in the body of the rodents. The metabolites excreted out differed from male to female in rodents. While males excreted the carboxylic derivatives of the parent compound, the female rats excreted the sulfate conjugates of carboxylic acid. The LD50 values of male and female rats was very different. While the LD50 value of female rats was 997 mg per kilogram, the LD50 for male rats was only 595 mg per kilogram. This vast difference in LD50 value might be attributed to this biotransformation. Tebufenpyrad exposure has been linked to cancer, but to date no human data has been conclusive enough to link the two. Recently, this pesticide has been shown to affect the dopaminergic neuronal cell lines N27 by disrupting the mitochondrial dynamics. Loss of dopaminergic cells have been linked to Parkinson's disease, in which the neuronal mitochondria are affected. These findings may show that Tebufenpyrad might also be able to affect the neurons. Overexposure of the pesticide has also led to the development of resistance among different target organisms. Recent studies have detected Tebufenpyrad resistance in 2 spider mite species in apple trees in Western Australia. References